Welcome to the course on Industrial Automation and Control. Myself, Dr.M. Prasad Reddy, working as Associate Professor at Institute of Aeronautical Engineering in the Department of Electrical and Electronics Engineering. In today's lecture, I am going to discuss measurement system specifications. So when you talk about industrial automation and control, the measurement systems are going to play a very major role, and starting from where you are going to measure the physical variables till the control, you may require the measurement systems. So measurement systems that including the sensors are heart of the industrial automation systems. So without measuring the physical variables, you cannot automate any process or any industry or any plant. So before going to discuss what are the various specifications of measurement system, first let's have a look at the general structure of measurement system. So what is this structure of measurement system? What you all require from the measurement system? First of all, there will be physical variables that generally we can call it as the true value or input. So that where you are going to utilize the sensors to sense the true value or whatever the variables you are interested to measure. Then from this particular measurement system, you are going to get the output or measured value. Suppose if you are going to sense the temperature through the thermocouples, what will be the output? How much value of output you are going to get? Whether you are going to get the 60 degrees centigrade or whether you are getting exactly it in the temperature in the degrees, or whether you are getting it as an electrical signal, that again you have to process to display it in a convenient manner. So here if you take any measurement system, first of all, the sensing element will be there. So this particular sensing element is going to interact with the process or physical phenomena where you are going to operate the machinery or process where the physical phenomena takes place. So this sensing element is going to directly interact with that variables. It may interact directly or indirectly, that depends upon what kind of sensors you are going to use. So this particular sensing element directly sensing what is the physical variables, and it is transforming that particular output to the signal conditioning element. Suppose if you are going to sense any physical variables, that may be you are going to get the output of the sensing element in the different forms. It may be the electrical signal, or it may be the change in the resistance, or it may be the strain, or it may be the displacement. You may get the any kind of output from the sensing element. Further, if you want to process that particular signal to the next stage, you may have to do the signal conditioning. Suppose if you take the by using the sensors, if you are going to get the output as change in the resistance, that is not useful for you. So you have to convert this change in the resistance into the electrical signal. How it is possible? If you are going to place this resistance in the Wheatstone bridge, then you are going to get the output as some change in the electrical voltage or current. So in the signal conditioning element, so here you are going to alter the properties of whatever the signals feeding to this particular unit. So you are going to amplify the signal. Sometimes you are going to perform the filtering, or sometimes you are going to change that particular signal from one form to the another form. So this is what can be done in the signal conditioning element. Most of the cases, whenever you are getting the change in the resistance as the output of sensing element, here you are going to place some Wheatstone bridge circuits. Those are going to convert the resistance into the electrical signal. Whatever the circuits you are going to utilize within the sensing and signal conditioning, compulsory here you have to get the electrical signal. Compulsory you have to get the signal here in the form of electrical. So this is very, very important. Now whatever the electrical signal you are getting from this signal conditioning element, that can be processed further. So what process you are going to do? Sometimes you are going to filter noise, and sometimes you are going to diagnose that one, and sometimes you are going to linearize whatever the output you are going to get it from the sensor. So here typically three things can be done. So one is the noise removal, and second one, here you are going to perform the filtering, and third one is here you are going to perform diagnostic. So these all the three things can be performed in the signal processing elements. So once you have processed this particular electrical signal, then you are going to feed it to the data presentation element, where actually you are going to display the values of whatever the input variable here you are going to measure, that you are going to display sometimes by using the LEDs or some LCD displays, or sometimes you are going to store whatever the data you are getting from the sensors through the recorders, or you are going to store the data. So why? Because if you take any plant, if you want to analyze further what is the data you are getting at each and every instant, you have to store that particular data, or sometimes for real-time control you may need to display the values. So that means here at the data presentation element, you are going to store the data, and you are going to record the data, and you are going to display the data at the various displays available. So this is the general structure of measurement system. And if you take the typical example of a measurement system, so how this, if you take any physical variable, how it can be done or how it can be measured through the measurement system, and what are the various blocks within this particular measurement system. If you take a practical example, here I am going to explain weight measurement system. So generally, if you are going to measure the weight of any particle or any body, how that is going to take place, that's we can see through this particular block diagram. Suppose here, what is the input here, or that is going to be true weight. So here you are giving the weight. I am interested in measuring the weight with the help of measuring system. So for this particular one, first of all, I am going to take the primary device, that is called the load cell. This is a mechanical device. Load cell is a mechanical device that is I am going to measure the weight primarily with the help of the load cell, that is a mechanical device. What this particular load cell will do? So it will convert this particular true weight into the strain. So whenever you are putting the weight on the load cells, it is going to experience some strain. So that means here primary you are going to measure the weight in terms of the strain. Now by using the secondary instruments for the measuring of the weight, so you are converting this strain into the resistance or change in the resistance with the help of strain gauge. So here for measuring this particular weight, I am using one primary instrument, that is the mechanical instrument called load cell. Load cell is converting the given weight into the strain, and I am going to convert the strain into the change in the resistance with the help of strain gauge, that is the secondary device. So here I am going to sense the weight through the two devices, that is load cell and strain gauge. Then I am going to sense the weight, and I am getting the output as change in the resistance. Now if I want to convert this change in the resistance into electrical signal, that is I am going to use the Wheatstone bridge. So if you are going to place this resistance in the any one of the arms of the Wheatstone bridge, then because of the change in the resistance, if the bridge is going to unbalance, then there you can see there will be deflection of the meters connected in the Wheatstone bridge. So whatever the change in the resistance, that is deflected as change in the voltage, that will be measured in terms of millivolts. Generally, if you are going to process these particular variables in terms of the lower voltage levels, that may be subjected to the noise through the communication channels. So you have to eliminate whatever the low levels of signals. So such what, if you want to transmit these signals through the communication channel, compulsory you have to amplify the signal so that you can remove the noise because of this particular communication channel. So now I am going to use the amplifier circuit here. So with the help of amplifier, I am converting this low level voltage into the high level voltage. I am converting from millivolts to the volts. Now I am going to process this particular electrical output, that is in terms of the volts, to the analog to digital converter. Why? Because I want to display my whatever the weight in terms of the digital values, so that I am going to convert this particular analog voltage signal into the digital signal with the help of A to D converter, and further I am going to process the same signal through the digital signal processing. Then finally it is going for visual display. So this DSP unit, digital signal processing, is helpful in displaying this particular whatever the weight measured in terms of some numerical values, that is through the visual displays. And finally, you are going to get the output or measured weight. So generally, here you have to understand, if you want to measure the weight of a body, what are the things required in this particular measurement system. There is a load cell, there is a strain gauge, there is a Wheatstone bridge, there is a amplifier, A to D converter, digital signal processors, and visual displays. And here you have to see there is a coordination and cooperation between all these particular elements so that it is possible to measure the weight. So if there is no amplifier, you cannot display the values accurately, or if there is no A to D converter, you don't know how to measure this particular voltage or current signals. Why? Because it is going to look like a waveforms. So if it is going to display in terms of the waveforms, the peoples cannot understand what is the value of that particular weight. So that's what you need to convert these kind of signals into some values like 0.7 volts. So you can understand very easily if it is going to display 0.7, if it is a voltage, or if it is a weight 1 kg means you can understand very easily. And instead of that one, if it is displaying in some magnitudes, it is very difficult for you to measure or find out what is the value. So that's what you may require all these elements to display whatever the exact weight in easy and convenient manner. If you want to display the value, you may require all this coordination. So this is a typical example of whatever the measurement system for measuring the weight. And coming to the characteristics of measurement system, why you want to know the characteristics of measurement system in an industrial automation course. In the next few topics, you are going to study completely about the various measuring instruments. If you want to measure the temperature, how we can measure in an industrial process, what are the various methods are there for measuring the temperature, for measuring the pressure, speed, displacement, acceleration. So all these things are required within the industrial applications. So now if you are going to automate any industry, first of all, you have to know what is the requirement of industry and what are the ranges of values you are going to measure and what kind of instruments you may require. Suppose if you are interested in measure the high temperature values from 100 degrees centigrade to the 1000 degrees centigrade, accordingly you have to choose the devices for measuring or sensing the variable of temperature. So for this particular purpose, you should have the knowledge of all the instruments or their specifications. So if you are going to buy any instrument in the market, there may be specifications written on the data sheet of that particular instrument. So through that particular specifications, if you are going to understand the specification, then you can design your process or you can automate your industry without any interruption. Otherwise, what is going to happen if the range of the instrument is 0 to 10 volts, and if you are interested to measure 10 volts to the 20 volts, sometimes even it is out of the range, it may give the readings, but whatever the readings you are going to get, that may be the false values. So that's what it is very, very important to know what are the various characteristics of instruments, so that when you are going to automate or whenever you are going to instrument in the applications, it is very easy and convenient manner to work with the industrial applications. So basically, if you take any characteristics of the measurement system, so these are of three kinds. So one is the static characteristics, second one is the dynamic characteristics, and random characteristics. So here in the static characteristics, you are not bothering about what are the changes takes place or how you are going to get the values. Suppose if it is the system, you are going to give the input here and you are going to get the output over there. So here you are not interested to know what is happening within this particular box. Simply, if you are giving the input, what kind of output you are going to get, what is the final steady state value. Suppose if you are going to sense the temperature, you are putting a thermocouple for measuring the temperature, but finally you don't know how the thermocouple is going to convert this temperature into the voltage, or it is going to display it. It does not require what are the changes takes place within it. Simply what final value it is going to settle, or what final reading you are going to get out of that particular instrument. that is of your interest. So that may be analyzed with the static characteristics. Simply here, static characteristics are at the steady state values. Once you are going to give the input to any instrument, it is going to give the steady state value. So you are more concerned about the steady state value while studying the static characteristics. In the dynamic characteristics, so these are related to the dynamic behavior of the system. So as you are continuously feeding the input, sometimes there may be continuously changes takes place within the system, and how fast you are going to reach the steady state value, that all you are going to study through the dynamic characteristics. Sometimes if you are going to take instruments, so it is if the rise time of that particular instrument is very less, means you may reach the steady state value within a very less time. If the rise time is more, means you may require the more time to reach the steady state value. And the third one, random characteristics. Suppose if you are going to perform measurements with the help of instruments, sometimes there may be errors occurs. So you don't know what are the reasons for those kind of errors. So those are inherent within the instruments that you may not find out. Such a kind of errors or the sources of errors you may not find out. But rather than that one, you are going to use some particular methods to analyze these kind of errors, and if you are following some methods, you can eliminate this particular kind of errors. So in the random characteristics, especially you are talking about the random errors which are unknown to the user, or which are that does not know what kind of sources are generating these kind of errors. So let's see one by one, what is the static, what is the dynamic, and what are the random characteristics. So static characteristics here more concerned only with the steady state readings, so that the instrument settled down to such that the accuracy of the reading, here accuracy, precision, range, all those things you are going to study. So coming to the dynamics, so these are going to describe the transient behavior between the time a measured quantity changes value and the time when the instrument output attains a steady state value in response. So you are presenting some input quantity, and here till what value of output or what steady state value you are going to get, in between what is going to happen, that you are talking about the dynamic behavior or transient behavior of any instrument. And coming to the random characteristics, so here the instrument reading may vary randomly due to the inherent sources of errors at any point of time. He does not know what is the sources of this kind of errors. And coming to the static characteristics of instruments or measurement systems, so these are the various characteristics are there for any instruments or measurement system. That is the range or span, accuracy, precision, linearity and sensitivity, repeatability, reproducibility, hysteresis, threshold, and resolution. So this we'll see one by one. So what is the range or span of any instrument? So if you take any instrument, that will be having a what is the minimum value you can measure through the instrument, and what is the maximum value you can measure through that particular instrument. Especially if you take a weight measurement systems that is available in the market. So if you want to measure 0 to 10 kgs weight, you may require a one kind of instrument, and if you want to measure 100 to 1000 kgs or in the other range, so you may be buying that particular range of the instrument. Why? What is that range means? So if you are using the instrument within the range, then only you are going to get the accurate and precise values. So if you are not properly choosing the range of the instrument, whatever the values you are going to measure, that may be deviating from the actual values. So that's what here the range or span of an instrument that defines the minimum and maximum values, of a quantity that the instrument is designed to measure. So for example, here you can see this is the thermometer here. So here it is, the range is given from 20 to 60 degrees centigrade. That is, it can measure the values from minus 20 degrees centigrade to the 60 degrees centigrade. Then what is the range of this particular instrument? So that is minimum value, maximum value minus minimum value. What is the maximum value? That is the 60 degrees centigrade. And what is the minimum value? That is the minus 20 degrees centigrade. 60 minus of minus 20, that is going to be 80 degrees centigrade. So that means, so this particular instrument is going to, this instrument having a range of 80 degrees centigrade, and it can measure the temperature within the span of 80 degrees centigrade. What is the span means? What is the difference between maximum and minimum value of the range of that particular instrument? That also we can call it as the span. Then accuracy. So if you are going to measure any instrument, any variables through the measuring instruments, so whatever the value you are going to measure, so if it is much close to the what is the true value of the quantity being measured, then we can say that the instrument is going to measure very accurately. Then what do you mean by a true value? How we can know whether the quantity you are going to measure, whether it is a true value or not? So you have the various methods to find out the true value. So there are primary instruments are there are secondary instruments are there. You have to calibrate against the primary and secondary standards, and you have to take this particular measurements into a standard laboratory where you can find out very accurately. By conducting the infinite number of measurements, you can confine to the true value. So you are going to calibrate these instruments against the standard laboratory equipment, which are more precise and more accurate. So from in that way, you are going to get the true value. Now, once you have calibrated your instrument and once you are going to measure any variables through these particular instruments, so whatever the value you are going to get, that we can call it as the measured value. So if the measured value is much close to the true value, then you can say that that instrument have the more accuracy. So generally, in case of this measurement system, so instead of talking about the accuracy, most of the times we can quote about the inaccuracy or measurement uncertainty values rather than the accuracy of an instrument. So most of the time, if it is not measuring properly, you can say that the instrument is more inaccurate, or the measurement having the uncertainty. So inaccuracy or measurement uncertainty is often quoted as a percentage of the full scale reading of an instrument. How we can improve the accuracy of any instrument means with the help of calibration. So if you are going to calibrate the any instrument against the standard laboratory equipment before using, so there is a possibility to avoid inaccuracy or measurement uncertainty in any instruments. Then precision. So precision, that is going to indicate the repeatability or reproducibility of an instrument. So if you are going to measure any value or any physical variable repeatedly and with the same instrument under the same conditions, if it is going to give the same values all the time, then you can say that that instrument repeatability is good. And reproducibility means, so if you are going to measure a single variable with the different kind of instruments, with the different situations, and if it is producing the same values, then you can say that that instrument are having the reproducibility. So here, if an instrument is used to measure the same input but at different instance spread over the whole day, successive measurements may vary randomly. So if you are performing the same measurement at the different timings of the same day, then you can find out there may be variations takes place in the measurements. So this precision of measurement instrument indicates that the successive reading would be very close, or in other words, it is standard deviation is small. Standard deviation means you are going to aggregate, you are going to find out the arithmetic mean of all the readings. Then you are going to talk about the standard deviation. So what is the deviation of the measured value from the arithmetic mean? That we can call it as the standard deviation. Okay. So precision means repetition of successive readings, but it does not guarantee accuracy. So these successive readings are maybe close to each other, but far from the true value. So here you can see what is the difference between the accuracy and precision. So here I have the these particular dots. This will show what is the various measuring readings. So this is my true value. So now I am talking about the accuracy. So whatever the readings I am going to measure, so if these readings are much close to the true value, then I can say that my instrument is more accurate. So here you can see the first one. all the readings, so that are very close to the true value. So that is, we can say that whatever the measurements we have taken, that are accurate values. And also there is not much deviation takes place within the measured values, so that are fall in the just plus or minus 1%, so that these readings also we can say that precise. So that is going to be accurate and precise. And here you can see, in the next instant, if you are going to measure the values, here you can see, so these values are more far from the true value. So these values are far from the true value, but whatever the readings you have measured, that fall under the very small range. So that's what we can say, that this is inaccurate but precise. So this value may be deviated from the true value, but whatever the measurements we have taken, those are precise. Then you can take the third case here. Uh, Whatever the values you are going to measure, so those are close to the true value, but these are imprecise. So that values are falling in a some large range. So that's what we can say, these values are imprecise, or whatever the measurements you have taken are imprecise. And here you can see the last case. So these values are already far from the true value, are deviating from the true value, and also fall in the large range, so that these readings are inaccurate and imprecise. So from this diagram, you can clearly understand what do you mean by accuracy and what do you mean by a precision. So if the measurements or readings are close to the true value, then you can say that the instrument is accurate. Even if we are getting the values close to each other, but if it is far from the true value, then you can say that it is inaccurate, but it is precise. And repeatability, so this is closeness of the output readings when the same input is applied repeatedly over a short period of time with the same measurement conditions, with the same instrument, same observer, same location, and same conditions are maintained throughout. So maybe temperature or humidity or pressure within the room, we have to maintain it as the same. And reproducibility, so this is the closeness of output readings for the same input when there are changes in the methods of measurement, or the observer may be different, measuring instruments you are going to change, location, conditions, and the time of measurement also you are going to change, but still whatever the readings you are taking, if it is close to each other, then you can say that the instrument have that particular measurement system having the reproducibility capability. Then threshold, if you take any instruments, whenever you are going to measure any physical variables, as soon as you are giving the input to the instrument, that is not going to read a value, output value. You have to provide a certain amount of input, then only your instrument is going to respond. So that is what we can say it as the threshold of an instrument. Suppose if it is the 2 volts, that is the threshold value of any measuring instrument. If you are giving the 1 volt as a input, the instrument is not going to read any value. It will show the output value is 0. But if you are going to apply more than 2 volts or approximately 2 volts, then only the instrument is going to respond. So this is the minimum value you have to apply to the instrument, then only it is going to give the or read the what is the input variable. Then what do you mean by resolution? So if the any instrument having the higher resolution that can respond to the even small changes in the input signal. So if the resolution is very low of any instrument, that means that even there is a large change in the input signal, the instrument is not going to respond to the changes in the input. If it is having a good resolution, means even there is a small incremental change in the input signal, the output is going to change accordingly. So this is about what is the resolution of any measurement systems. So here you can see, here you have the input and here you have the output. So this is the incremental change delta I. So resolution equal to delta I, that is the incremental change by I max minus I minimum. So I max minus I minimum is, that is what about the range of instrument. What is the minimum value you can measure? and what is the maximum value you are going to measure. And sensitivity. So it is the ratio of change of output of an instrument to the change in the input. Suppose if you are going to give the input by 20 degrees centigrade, if you are going to change the temperature of the input, how much you are going to get the variation at the output, that is all about the sensitivity. So here when you are going to define the sensitivity, you are going to assume that the input and output characteristics of the instrument is approximately linear in that particular range. So that is very, very important when you are defining the sensitivity. Suppose, for example, if you are taking a spring balance, the sensitivity of spring balance can be expressed as 25 mm per kg. Now, what it mean? So, if you are indicating the sensitivity of this particular spring as 25 mm per kg, that means if you are going to change the weight by 1 kg, then there may be a displacement of 25 mm in the spring. So that is what we can say sensitivity. So sensitivity of an instrument may also vary with the temperature or other external factors. Even if that we can call it as the sensitivity drift. So because of the change in the temperature, the sensitivity of that particular instrument may vary. And the other one is linearity. So linearity is defined as the ability of an instrument to reproduce its input linearly. So now here you can see, so this is the linear curve. Now if you are going to use this particular instrument for measuring any values, so whatever the measurements you are going to take from this particular instrument, so whether these are following the linear curve along with the straight line, or whether there is any deviations takes place, that can be known with the help of this particular characteristics, that is called linearity. So linearity is a measure of the maximum deviation of the calibration points from the ideal straight line. So here you can see this is the output values. So there is a deviation takes place from that particular straight line. So linearity in terms of mathematically you can say delta O by O max minus O minimum. So this is the max minimum value, this is the maximum, and delta O means, so what is the variation of this particular variable from this particular straight line. So delta O is nothing but maximum of delta O1 comma delta O2. What is the maximum deviation from the straight line or calibrated point. Now hysteresis. So it is a phenomenon. So this is going to depict different outputs effects when loading and unloading. So for example, if you are taking any mechanical system, so here if you are going to loading that particular instrument or a system, here the stress within the parts or the parts within the machine is going under stress. But whenever you are going to unloading, so these are not recovered from the earlier condition. So that whenever you are performing the loading or unloading, or whenever you are exciting or whenever you are removing the inputs, the response of the system is not same. So whenever you are loading, the response of the system may look like one way, and whenever you are unloading, the system response may be different. This kind of nature we can call it as the hysteresis. So you can find out this kind of nature in all the electrical system, mechanical system, and any other physical system. You can find out this kind of the phenomena. And the second type of characteristics, that is the dynamic characteristics. So this is completely related to the dynamic behavior of any measuring system. Soon after you are going to apply the input to the any system, what are the things takes place till the steady state value, that we are talking about the dynamic characteristics. The first one is speed of the response. So it is defined as the rapidity with which a measurement system responds to the changes in the measured quantity. So if you are going to provide any input to the measuring system, how fast, how rapidly it is going to respond, or how rapidly it is going to change the output quantity, that we can say it as the speed of response. And measuring lag. So it is the retardation or delay in the response of a measurement system to change in the measured quantity. So if you take a different kind of measurement system based on the resolution, based on the sensitivity of the measuring instruments, so soon after you are going to apply the input to the measurement system, sometimes it may respond very quickly, or sometimes it may take some time to give the output. So that we are talking about the measuring lag here. So retardation type means the response of the measurement system begins immediately after the application of input, and in the time delay type of measurement lag, so the response of the measurement system begins after a dead time after the application of input. So because of dead time, what is going to happen? The response of the system on the time scale is going to delay by some particular time. The response of the system is going to delay on the time scale, whatever the dead time we have. Dead time means till the dead time completes, there won't be any output. The output of the measuring instrument is going to be 0 till the dead time. And fidelity. So fidelity, it is defined as the degree in which a measurement system indicates changes in the measured quantity without any dynamic error. Suppose if you are going to continuously feeding the whatever the input variables to the measuring system, it has to dynamically change the output values without any error or without any deviation. So if the instrument having a good fidelity means if you are going to change any input, immediately that particular change will appear in the output also. So even if you are feeding the new input till you are going to get the output as the for response of the previous value, then we can say that that is a dynamic error. So it is the difference between the true value of the quantity changing with the time and the value indicated by the measurement system. If no static error is assumed, that we can call it as the dynamic error. So this is also we can call it as the measurement error. Then what is the dynamic behavior? So dynamic behavior of the measurement system is studied by using the time domain analysis and frequency domain analysis. If you are going to perform the time domain analysis, so there you are going to talk about what is the rise time, what is the overshoot, what is the settling time, what is the peak overshoot. All those things you are going to study about the time domain analysis. So when you are going to the frequency domain analysis, so there you are going to talk about what is the resonant frequency, what is the bandwidth. All these are going to play a very important role when you are going to study about the measurement system in the practical applications. So this is 5 dynamic characteristics. So one is the speed of the response, measuring lag, fidelity, dynamic error, dynamic behavior. And random characteristics. Suppose if you are going to perform the repeated readings of the same quantity measured by the same instrument under the same conditions, and when you are plotting all these particular values and they are going to differ from each other due to the inherent sources of errors of the instrument. And if you look at all those particular values, so that may spread randomly over a curve if you are going to plot those particular values. And it is very difficult to say what would be its value. So why? Because if you are taking all these measurements and if you are going to plot, all these measurements are going to spread randomly throughout the various axes. There you cannot confine to the what is the final value or what is the exact value of your measuring instruments. Why? Because so these particular errors, you does not know what are the sources of errors. So for that particular to find out what is the final value or exact value, you have to take some statistical methods. So by applying some statistical methods to these particular random values, you can find out what is the true value or what is the deviation or what is the error takes place within the measurements. So here for this one, we are interested in studying what is the mean and standard deviation of this particular random to analyze the random characteristics. So the mean of a set of readings is the most accurate estimation of the actual value. Why? Because if you are going to calculate the mean of this particular one, you are going to add all the values. If the values are some values are positive, some values are negative, those are going to cancel each other. So this is one of the more appropriate way to find out the actual value. And also the standard deviation is a measure of the spread of the readings. So here this is the mean. Here you can see whenever you are going to measure this particular value. So here all these particular measurements are spread around some center point. So here here you have the 100. So on the left side, on the right side, all these particular values are spreaded out. So like that, if you are going to measure any random characteristics and if you have taken the values, so that may be random in the nature and that may be fallen around a particular value. That particular value we can call it as the arithmetic mean value. So this is the most probable value of measured variable in arithmetic mean of number of readings taken, and it is given by x bar equal to x1 plus x2 plus and so on xn by n. So where x1 is first measurement, second one x2 is second measurement and xn is the nth time when you are taking the measurements, that is given by sigma x by n. So that is x1 plus x2 and so on xn by the total number of readings you have taken. Then what is the deviation? So it is a departure of observed reading from the arithmetic mean of the group of readings. So you have taken the value x1 and you have the arithmetic mean already calculated, that is the summation of all the values by the total number of readings. How much deviation takes place from that particular mean value, that we can call it as the deviation. So d1 is deviation of the first variable x1, that is x1 minus x bar, and here you are going to get the deviation of the second variable, that is x2 minus x bar. Similarly, so the deviation is given by d bar equal to the summation of all the deviation by the number of variables you are going to take. So this will give you the what is the deviation. Now the standard deviation, so it is defined as the square root of the sum of the individual deviations squared divided by the number of readings. So this is the deviation we already calculated, that is what is the individual value minus the arithmetic mean value, that we can call it as the deviation. So that is here it is the square root of the sum of the individual deviations squared by what is the number of readings, that will give you the standard deviation. So especially these particular characteristics, random characteristics are very much useful to estimate what are the approximate reasons for errors, so that you can correct in the measuring instruments. So here in this class we have studied about the what is the general structure of measuring instrument, and we have seen one example like how we can measure the weight with the help of measuring system and what are the things you require in a measuring system to measure the weight. Later we have seen the three kind of characteristics. One is the static, dynamic and random characteristics. So in the next class we will see what are the various kinds of measuring instruments are available to measure the physical variables. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.